Я представляю следующего докладчика. Матиас Бертлинг расскажет про цифровую фабрику на одном очень интересном инновационном практическом примере. Please.
Okay. So, hello again. My name is Matthias. Maybe you followed the keynote this morning where I introduced Ego, and in this session I will give you a deeper insight in how we use the tools and how we build actually our model. So what I do at Ego and normally do at the institute where I work in parallel, we do factory planning. So that means we are planning factories for our customer, and one of the customer is Ego. Yeah? I'm responsible for factory planning at Ego, but we also have many other projects. And we always start thinking about strategically on how is a factory built, how is the process behind this, how do I use the tools, and which tools should be used for which task. The Ego is only one of our projects, as I mentioned, but of course it's a very important project for us. We built a factory. This factory is in Aachen. Aachen is in the most western city of Germany, so pretty far from here. And we built a factory for 10,000 vehicles in a run-shift operation. We have 130 employees, and we have a cycle time of 10 minutes, so very unusual for automotive industry, very long cycle time. We have a little automation, but we have very high automation of the information model. So that's why I'm very interested in your presentation, even if I not understand everything, but I saw that you connect many systems. And this is also what we do in our production, and I had a presentation yesterday where I showed our digital shadow, and we have many systems like PLM, CAD, ERP, MES systems in place for our production, but on top we have systems for the factory and the factory planning process. Yeah? On this slide actually you see different stages of the planning process, and we always compare this to like a structure where you have a force, and there are different solutions and different tools how you can calculate this. There's a very simple tool, a very simple solution, but there's also a very complex solution. And in different stages of your production planning project, you need different tools. So it's as I mentioned this morning, it's okay in the beginning to have a very simple tool. So we do a lot of workshops with our customers which are paper-based, which is a creative process. We discuss a lot. We don't need any IT system there. We only document, and then we try to transfer this in PowerPoint layouts. We just move quickly the different elements, and we start to build a production concept. And this is very simple, and you don't need a highly sophisticated IT system behind that. But on the other hand, we have also like participating methods, for example, where we do some very fast modeling of what the customer actually needs, and then we have like it's like a table, and you can work with this table and show the layout to for example to people working in your production line, and they can move objects, they can improve, and you can develop a layout out of this. This is already the second step. It's also a tool we use in our daily projects. But also we are sometimes, as I said, we are paper-based. You see a picture here. This is in our Ego factory in Aachen at a very early stage, and we also do like a cardboard engineering. So we really built this in paper as a real cardboard engineering assembly line. We will see this assembly line later. This is our rear axle assembly. We will see this later in virtual reality. But as you see in the beginning, our models are very simple. It's not like the nice pictures I showed this morning. This is nice for presentation, but the reality we work with, it looks like this. We have a okay, we have the building structure already because this is already built, but the production line, it was empty this time, yeah? So there was nothing built, but we had the model. We didn't know how this station exactly looks like, but we used like simple blocks to just block this area. And so we knew already, okay, we can't move there, we can check if we can see each other, if you have the material supply planned, and so on. So it's very rough level of detail, yeah. And during our process, it's getting more and more detailed. The next step actually is like here that we get first data from supplier. So this data here is integrated from our assembly line supplier. And as you see here, this is also not a very high level of detail. It's not very colorful. It's just white, and we just placed it here. But we already did in Navisworks, I will show this later, you have the opportunity to walk around like this walkthrough function, yeah. And we already checked, for example, if it's in the right place, if the process, we can simulate the process, we walk through the model and do already first checks. So I introduced this morning this planning cycle. I don't know what's, okay, now it's working. Yeah, with a plan, design, validate. This validation is very important for us because we need to design a factory or workspace which is very comfortable for all the people working there, which is functional. And we actually stick to this cycle and try to integrate more and more tools. Yeah? Right now we started very basic 2 years ago and only had this 2D PowerPoint layout, and then we got in contact with Autodesk and we started with Revit and Inventor and AutoCAD. And now I will show you different examples for each of these phases and how we use it actually. First, actually before we use AutoCAD, I said we do a lot of workshops, concept work. We do this in paper or with PowerPoint or very simple tools, or our planning table, very simple tools to plan the first layout. Then we integrate this into AutoCAD. It's always two-dimensional, just this areas and space and layout management planning. Yeah, this is the basic work you have to do, and most of you do this today. It's as a factory planner or industrial engineer. This is normal work. Yeah? Then in a second step, a little bit slow. Okay, so then we still use a factory design suite. We have all the elements in there. We use these elements. We get the data from supplier. We modeling our own elements, but there's also a big database from Autodesk provided with the factory design suite. And we use these models to generate better layouts in the end, and to start with the 3D planning. And the 3D planning is done in Inventor, which is now directly connected to this cycle. So you also see the different formats here. Yeah, we are exchanging formats we use, but mostly the architects, they are working with Revit. It's like 70% of the construction projects in Germany, they are conducted in Revit. Every architect uses that software, mostly every architect, so it's normal to get data in Revit format. So we use this for our whole building planning. Yeah, you can also use that for inventory and production planning, but we found out that actually the 3D is in Inventor is pretty much simpler, easier. We have some more functions we need which Revit cannot provide, so we decided to build our 3D model here. But just to mention, it's also possible to build everything in Revit. Yeah, that always depends. There is not one solution. It always depends a little bit on what you really want to do with your data. And then in next step, actually we have a building model in Revit, production model in Inventor, and now you have to bring this together. Yeah, and we do this with Navisworks, but this now is not working. Yeah, you see here we use Navisworks for coordination of these both models to bring together production and building. in the different stages. It's not always a very nice model, it's a functional model we use for the daily planning. And based on this Navisworks model here, you already have the walkthrough function. You can do a lot of validating here. You don't need very nice renderings or something. You can just walk through the model. But if you need to have a nice renderings, for example, you can use 3ds Max. We use it to make our models look a little bit more nicer. And then we used an Unreal Engine to create a virtual reality environment. Yeah? So this makes the model more nicer. This one makes us enables us to walk through the model and to have a 3D virtual reality application based on that. And this is also where we do our validation and we feedback this information. So right now, actually, if you have the virtual reality application, it's not easy to feedback this into the Revit model. Yeah. So actually, we do like workshops and then we adjust the model. Yeah, I think there will be more development in the future to make this easier. But this is now one way which worked very good for us to use the systems to have a 3D planning for building and production layout. The one interesting point, the EFC format is also very commonly used in all the BIM standards. We try to find the right, let's say, criteria and the right attributes for all the elements. And work on that, so we constantly improve. Yeah. So our models right now, as you see in the morning, they are functional, but we still developing a better cycle. So these is the overview of the systems, and now we have a short look at how everything looks like in the real model. The first one is so this is left side is PowerPoint, right side is AutoCAD. Yeah. We do all this very first concept work we do on the left side in PowerPoint. We just move the squares. Everything is nice and it's very easy. Everybody can use it. You need no license. Everything great, yeah. But then the point comes where we have to transfer this, and then we never use this anymore. This is only for the conceptual work, and after that, one day we switched to AutoCAD and we started with a 2D layout, and actually pretty easy to copy that. On the other hand, we have this building model. This is our Revit model from our architecture model. There's a lot of parameters and attributes behind that, but this is done in Revit, and this pretty much looks like you see here. And this is the Inventor 3D model of our inventory. You actually see the 2D layout in the background. And based on this layout, we start to generate and to build up the production step by step. And here, for example, this is quite interesting. You see a lot of integrated data, but this machine here, we haven't ordered yet. We don't know how it looks exactly, but we already put a square here, which pretty much looks like the machine we get. Yeah? And later in the nicer model, you will see how the machine really looks like. So we just reserved the space. Yeah, this is a rain cabin where the finished car is getting tested in this area here. Wheel alignment, brake test, and then this is a rain cabin we use, and then we have all the end of line process here. But we haven't received the data from our supplier yet, so we just put a square there. Yeah? So pretty simple, but it's functional for how we work. What you're not seeing right now is the building. Yeah, this is only the Inventor model, but now we need to bring this together because we need to validate always production with building, and that's how it looks when it's coordinated in Navisworks. Yeah, now you have the building plus the 3D Inventor model of our factory. And that's how it looks in nice rendering. Yeah, so there is you see a clear difference. Yeah. This is how we use it in everyday work, and this is what you can make out of it when you have a very strong engine and rendering program behind you and very nice marketing guys from Autodesk doing good work. It looks like this, yeah. But as I mentioned this morning, this is still the working model. We are working in this area. We are working in this area. We don't have the machine data yet. It's just our concept. But you see here now in this step, we already got the machine. It's placed here. We received the data from our supplier and we integrated it in our model. So different steps of maturity and different steps of granularity of the model. But we always start with a very, very simple process. This is this kind of walkthrough function we use to walk through our model. Yeah, this is like eye level, a little bit higher. You can walk and you can already validate, and this is totally enough for our industrial engineering experts to validate everything they are planning. They don't need more. They can also work with 2D, but this is much nicer to work with. And that's how it looks in a nice rendering. Yeah, this is our assembly line. We have, I said, we have 28 stations in a U shape. On the left side, you see the rain cabin. This is an autonomous transport system which transports the car through the whole production line. We have a lot of overhead construction here with a media supply and light and worker instruction, but it's still a pretty manual process. With this model, we do like virtual reality validation. So our industrial engineers, they always can use, we have like an extra room for that. We have the model updated, so it's pretty easy. They can, within minutes, they can start, and we do like weekly workshops on the current status of our layout. So for example, in our regular meeting every Monday, we use the 3D model and also the virtual reality model to go through the model and check if all data is there, if the planning tasks are fulfilled, if the right level of detail for every station is already there. And mostly we have very concrete questions before we start the meeting, and then we validate our questions in the meeting, and that's how we use the model. Yeah, this is also end-of-line testing. Here we have our filling station, means media filling for brake, HVAC, cooling pipes, and so on. And we can do, because everything is pretty packed, it's very close by, you don't have much space in a car assembly line, so you really need to plan, okay, where do I place my racks, where do I place my toolboxes, what is the movement area, where do we place additional handling devices, yeah, so we can all plan this in a 3D model. This is again the assembly line. We saw this as a block, as a wide supplier data, and this is how it looks in the final model. This is with real parts. Yeah? So we integrate the real parts from PTC Creo, from our developing systems, to validate the assembly processes. We optimize our workspace here, the working stations. We can check for ergonomic arrangement of everything. We can check with handling systems, and we feedback this, we change it in the model, we give these screenshots to our supplier with some remarks, please change that, yeah, and try to have a closed loop. This is one concept. This is not the final model, but this is what we pretty fast generated to check how we supply our material at the station. Yeah? You see our tugger train supplying the material. This is for front axle, this is for rear axle pre-assembly, and we checked how do we get the material here. You see all the rest here is still pretty empty. This has been for one workshop for optimizing the assembly line, and we always try to validate our processes with our 3D model in the end. And you have to start the video, which I showed also in the keynote presentation. It's very nice to validate this on the construction side. So what we see here in this video is only the Revit model we validated, but we also validated our Inventor model on the not on the construction side, but once the production hall was finished, we took our Inventor model and then we walked through the factory, and we can see in augmented reality, okay, there will be the rain cabin, there will be the end of line, this will be a walkway, yeah, and we can check our planned model and actually the empty production. This is a very nice function, especially if we get very big. This rain cabin is very big, and we can check before this rain cabin arrives, do we have all media at the right place? Is there enough space when the machine comes in? And so on. There are many questions you can pretty easy answer with this 3D model of your factory. And this was not very complicated. So 2 years ago we had no idea of Autodesk products. So we are also pretty new to the Revit world, Inventor world, BIM world. Yeah, of course at the university we use it and we do research on that. But as a real user, this is new to us. And we started to qualify a lot of students, assistants or students at our institute at EGO to work with the software. And this wasn't pretty hard. I thought it's pretty hard to motivate the people, but actually it was quite easy, and we were able within 1 year to generate all these results we have. So this is all done by us actually without any big knowledge beforehand. So it's pretty easy to learn that, and so I can just motivate you to get started with that. You don't need the full 3D factory in the beginning. You can start very simple with only Revit and Inventor, and then you can develop and increase your level of detail and become like a fully twin of your factory in 3D. But really start very easy, but start with that, and that will be much easier later. Once you have these basics, and once you have the architecture of the IT systems, it's very easy to use that later. But we still have some time, yeah. Thank you.
Матиас, вопросы, возможно? Секунду.
Hello, Matthias. My name is Nick. Thanks for your speech. A short self-intro to give some context to my question. So I lead a company called BIM Machine, and what we do is kind of Uber for AEC companies. So we offer engineering services on the distance. We have a lot of point cloud processing work and a lot of modeling, including Revit. I saw in your deck one slide that you were saying that you have used laser scanning for comparing the as-builds. So I assume that you've generated the models, and we're interested in how you do the as-builds and what do you use for this laser scanning for, and how do you operate it? Because actually, if I got it correct, so this is a brand new building, right? So it's not the as-build. So you can give more facts about how did you use laser scanning?
We used laser scanning during different stages of the construction process. So actually, same time when we have this augmented reality app, we use this in the video. Mostly at the same time, we did a scan of the factory, because we wanted to validate planned versus build, work in progress, and we did a scan, and we found out that actually, some of the pillars moved like 10 centimeters out of what the model is. So 10 centimeter is already quite a bit, in construction it's normal, but the scan actually proved what the reality is, and so after that we adjusted the Revit model to the scan, so that we have the right position.
Can you name the app you used for this comparison?
For the comparison, I don't know it exactly. But I can find out. If you know.
Actually, no, because I do know that we do the point cloud processing, and there is no tool, and at least not the tool that we know that can do the comparison. I mean, from Autodesk, there's third-party tools who do the comparison.
No,
in our case,
it's a third-party tool.
In our case, we wrote our own software to compare this software, to compare the point clouds to point clouds, and then to deliver the deviations. But so far, I don't know this tool from Autodesk. So if you could name this, it will be awesome.
Yeah, I can find out about that. We can exchange. So later, I can give you some information on how we did this comparison. Because we have at a campus in Aachen where we work, we have a partner for modeling all the models. They're helping us. They are an Autodesk partner, and they're helping us to set up the model and also do some of the tasks like this augmented reality app. and I can ask them and let you know. But we also used scan in an existing building. We not only have a brand new building.
One more question about the scanning process. Did you use laser scanning or did you use photogrammetry? I'm asking because we have the experience of scanning vast objects, and I don't know how big is your facility, but one laser scanning can take you, I don't know, 15 minutes. And how many stations you need to scan the whole area? Did you use anything like Nevis or Revit reality capture things, or something like Paracosm, what uses not laser scanning but photogrammetry? Or did you use plain HDS scanners like Faro or Topcon or Leica?
So same here, we had an external company doing the scan. As far as I remember, we used the Leica cam in this case. I'm not exactly sure which camera, but same here. I can find out. It's good that you ask, and I think I remember when we did the scan, we had many points to scan. It took us 1 day for the factory. It's 15,000 square meter. This building, 8 and 7. So it took us more than a day to do the scan in an empty hall. Okay.
Еще вопросы? Спасибо.
You're welcome. Thank you very much.
Всегда интересно послушать доклад по практическому применению такого широкого набора инструментов Autodesk. И не только Autodesk, как выяснилось.